Problem 3. Raleigh is going on a walk. She can go two ways. She has two choices. She can go on an all-flat road, or she can have a road that's half uphill, half downhill. The total amount of time she used walking both ways is the same. The speed going downhill is 1.6 times the speed going on flat road. So what is the fraction of the speed going on flat road is the speed spent going uphill? So we have three different types of speeds. So we have the flat speed, the uphill speed, or the downhill speed. We know, well, let's first set one of them because we don't know, we only have ratios here, so we don't know the exact numbers. In a lot of terms, when we have ratios, fractions, you know the relationships, but you don't know the actual numbers, you can just give them numbers because that as long as they follow those rules, those relationships. So for example, we can set the speed going flat as 10. And we can spend the speed going going downhill as 16. And the speed spent going uphill, well, we don't know yet. And also for the distances of both of these roads, we don't know. So we can just give them a easy to calculate, a easy to use distance, right? So I'm going to give it 160. So this entire thing would be 160. So this would be 80 and this would be 80. Okay, so now 160 divided by the speed, 10, is equal to 16. So it took 16 60 minutes, 16 hours, we don't know, to go to travel this entire thing. So, for example, this is downhill. So 80 divided by 16 is equal to 5. It took 5 minutes, 5 seconds, 5 hours to do this section. It took 5. But in the problem, we also know that the total amount of time used for walking both ways is the same. So if this took, say, 16 hours, so I'll set it as 16 hours, we don't really know, and 5 hours over here, then this part will have to be 11 hours. So if the time here is 11 hours, and this is the total distance, we're trying to find its speed, then we can do 80 divided by 11, which is 80/11. So that is our final answer.